Okay, look at these examples. So it's the same that you need to prove that this differential equation is true, right? Asking to prove that means that this is already true, that you just need to prove that you need to use what you have here to show that this is true. So now you have y equals to ln. So always, student, that's the problem here is before you proving, you have to know how to differentiate this whole thing here, right? So this is the function where, okay, to differentiating, so then you have ln cos cube. You know that cos cube means that cos 2x to the power of 3. Right? And you must remember this is a ln, right? Ln. Always remember that is a ln. If this is a ln function, you have to apply the rule of logarithmic. It's even easier, right? If you want to differentiate ln directly, it means that now you 1 over, you have cos cube, right? So then you need to differentiate this one. So it's a bit difficult. So for me, I suggest that you bring down the 3 because why? This is ln, right? You can use the law of logarithm. So you bring down the 3 first before you calculate. Before you differentiate. You are not differentiating yet, so you are just simplifying. So now you have 3, right? Cos 2x. Now with this line, then it becomes easier to differentiate. So I start differentiating. So dy dx, dy dx. So this is a constant, right? Constant. So differentiating ln. Then you must remember the formula of differentiating ln. So we 1 over cos 2x. You have to 1 over cos 2x. Then differentiate the function inside the ln. So differentiating cos, what's the formula? Differentiating cos, you have a negative sine 2x, right? Negative sine 2x. And not finished yet because you need to differentiate the angles of the cos. So you're getting 2. So finally you have negative 3 times 2. Negative 3 times 2. You have negative 6. Then you have sine over cos. Can you see that? If I rewrite, this one will be sine 2x over cos 2x, which is a ratio of sine to cos. I can rewrite this to be negative 6 tangent 2x. So finally, you get dy dx to be negative 6 tangent 2x. At least you know how to do, right? Dy dx here. But you still need the d2y dx2, right? You need to differentiate this for one more time. So let's see. So d2y dx2. So second derivative. So differentiate negative 6. Oh no, negative 6 is a constant, right? So you just need to differentiate tangent. So you have to remember the 6th formula for differentiating trigonometric. So differentiating tangent will be secant square, right? Secant square 2x. Secant square 2x. But you have to differentiate the angle as well. So you have 2, right? Differentiate 2x, you have 2. So it means that your d2y dx2, you are getting negative 6 times 2, negative 12 secant square 2x. So I'm going to jot it down. So it means that my dy dx, I'm getting negative 6 tangent 2x. And my d2y dx2, I will getting negative 12 secant square 2x. Alright, then I'm going to, I already showed that how you differentiate y and d2y dx2. So now I'm going to erase everything here. I'm going to show that this is true, right? Alright, I've just now to show you how to find dy dx from here and how to find d2y dx from this, right? So now we're going to using this value here, what you get here, to proving this is true. So of course this one I will using the left hand side. The left hand side, which is 3 d2y dx2 plus with dy dx to the power of 2 plus with 36. I cannot write equal to 0 because I have to prove this is really getting 0, right? So I just using the right hand side, left hand side here. So what I have here, d2y dx2, right? So I plug in what I have. So then I want to prove that it's getting 0. d2y dx2. From there you are getting negative 12 secant square 2x plus with dy dx square, right? dy dx square. So dy dx is negative 6 tangent 2x plus with 36. You just need to using this and proving that it will be equals to 0. So of course you see that is a trigonometric. So they must be using a trigonometric formula. So 36, negative 36, second square 2x plus with negative 6 square, right? Negative 6 square is 36 tangent square 2x plus with 36. Then we try to observe but for now we can't see is equal to 0, but we know that tangent square and secant square, they have a relationship. If you still remember that the three famous identity, the Pythagorean identity, you know that sine square plus cos square theta is 1, followed by tangent square theta plus 1 equals to secant square theta, followed by 1 plus cotangent square theta equals to cosecant square theta. I think this is the one that we need here, right? Because, okay, from here I can modify because the theta here, based on here, is 2x, right? 2x. So I know that tangent square 2x, I just modify. So plus 1 equals to secant square 2x, right? From here. So either I replace the secant square with tangent square plus 1 or tangent square with secant square minus 1. So I'm going to replace secant square with tangent square 2x plus 1. So let's see, can I getting 0, negative 36. So secant square 2x is tangent square 2x plus 1, right? Based on this identity here. So plus with 36 tangent square 2x plus with 36. Okay. So if I expanding, I will getting negative 36 tangent square 2x, right? Negative 36 tangent square 2x, negative positive, negative 36, right? Negative 36 plus with 36 tangent square 2x plus with 36. Finally, I can see that negative 36 plus 36, you are getting 0. Negative 36 tangent square plus 36 tangent square, so you're also getting 0. Finally, is equals to the right hand side, 0. So it means you have proven that, you already proven. So it means therefore, you have proved that, you state back, so that the 3 d2y dx2 plus with dy dx to the power of 2 plus with 36 equals to 0. Proof, right? We have proved that this differential equation is true after differentiating. So I think that's all. Hope you can get some techniques while doing this, as they have different type of question, they have different type of techniques. So you need to be very good in arranging and differentiating all the algebra skill. So then you need to do more practice so that you getting better in doing this type of problem. Okay, that's all.